Good day everyone, I am Fatima Hashmin C. Abdul Madid. So today I'm going to talk about our activity number 4, which is factors affecting solubility, nature of solute and solvent. Before that, there are my objectives: to define what is solubility means, to understand the factors affecting solubility, to understand and observe different solution of solute and solvent. So, what is solubility? In general, solubility is an ability of a substance to dissolve. In the process of dissolving, the substance which is being dissolved is called a solute, and the substance in which the solute is dissolved is called a solvent. A mixture of solute and solvent is called a solution. So, these are the factors affecting solubility. Temperature. Basically, solubility increases with temperature. It is the case for most of the solvents. The situation is though different for gases. With increase of the temperature, they become less soluble in each other and in water, but more soluble in organic solvents. The next is the polarity. In most cases, solutes dissolve in solvent that have a similar polarity. Chemists use a popular aphorism to describe this feature of solutes in solvents. Like dissolves like, nonpolar solutes do not dissolve in polar solvent, and the other way round. Pressure. Solid and liquid solutes. For majority of solid and liquid solutes, pressure does not affect solubility. Gas solutes. As for gases, the Henry's law states that solubility of gas is directly proportional to the pressure of this gas. This is mathematically present as P equal to Kc, where K is a temperature-dependent constant for a gas. A good proof of Henry's law can be observed when opening a bottle of carbonated drink. When we decrease the pressure in the bottle, the gas that was dissolved in the drink bubbles out of it. Molecular size. The larger the molecules of the solute are, the larger is their molecular weight and their size. It is more difficult it is for solvent molecules to surround bigger molecules. If all of the above-mentioned factors are excluded, a general rule can be found that larger particles are generally less soluble. If the pressure and temperature are the same, then out of the two solutes of the same polarity, the one with smaller particles is usually more soluble. Stirring increases the speed of dissolving. Stirring does not have an effect on solubility of a substance, but everyone knows that if he puts sugar in his tea and does not stir, it will not dissolve. Actually, if we left the tea to stand for a long enough time, the sugar would dissolve. Stirring only increases the speed of the process. It increases move of the solvent what expose solute to fresh portion of it, thus enabling solubility. As molecules in liquid substances are in constant move, the process would take place anyway, but it would take more time.
Cooking oil plus water. When you mix water and oil, you will spot a bubbles. Cooking oil plus alcohol. When you pour alcohol into the oil, the alcohol floats on top. Cooking oil plus gasoline. The gasoline effectively dissolves the oil. Disinfectant plus water, alcohol and gasoline. Zonrox plus water. Zonrox and water mix well together. Plus alcohol. Zonrox and alcohol mix well together too. Zonrox plus gasoline. Zonrox and gasoline do not dissolve well. Ink plus water, alcohol and gasoline. Ink plus gasoline.
Gasoline and ink.
Ink and gasoline do not dissolve well.
And this is the alcohol.
Ink
and
plus
the
alcohol.
Ink. The alcohol and the ink.
Ink and alcohol are mixed well together.
And this is the water and the ink.
Ink plus water. Ink and water dissolve well too.
In my generalization, at a given temperature, the maximum amount of a material or solute that may be dissolved in a given amount of another substance. It is a physical property of a substance that determines whether it is polar or nonpolar, and the strength of any intra and intermolecular interaction that may prevent dissolution based on its chemical makeup. Good day everyone. So today I'm going to tackle about the activity number 5, which is the factors affecting solubility pressure. Factors affecting solubility pressure. It affects solutes in their gaseous state more than the ones in a solid or liquid state. The solubility property of a gas is said increase with the increase in partial pressure of the gas. In my observation, when soda is shaken, the gas from it escapes more quickly, resulting in more fizz than usual. Tiny bubbles caused by a shaken soda help the carbon dioxide in it escape more rapidly. Once the bottle of soda is open, the gas escapes, commonly referred to as going flat. By the way, other ways to get your soda to go flat include dropping, throwing, or rolling the soda. When the soda is shaken, the gas from it escapes more quickly, resulting in more fizz than usual. Generalization. To a certain extent, the higher the pressure above a liquid, the more gas that can be dissolved in that liquid. The solubility of gases is proportional to their pressure, and as the pressure rises, so does the solubility. A drop in pressure, on the other hand, diminishes solubility. That's all. Thank you for watching.